Hey class, sorry for the delay in this video. It's on 6.3. This is the handout I gave you in class today. And this handout is not posted on the wiki. I printed it and handed it to you today. So we're going to start by comparing 6.3, section 6.3, to what we did yesterday. Okay? Actually today in class and last night's video. So yesterday I told you every time your if was that you had a parallelogram, and then I asked you throughout the class what were all the thens you knew. Today we're going to take each one of those theorems and we're going to flip them or make the converse. Remember, we just take this and switch places. So on page 401, I want you to open your book to page 401. Hopefully you brought your book home. You'll see a nice yellow table. I'm going to pull it up for you in a few minutes, okay? And when you pull that up, it goes through all the ways to prove a parallelogram. So the parallelogram is what we're proving now, and we have these minimum requirements to be able to prove that. And there are 6 different minimum requirements, okay? So go to page 401, fill in the rest of these items here based off the theorem number, and make sure that after your then for every time is a parallelogram. You should now be able to answer question number 2, and I'm going to jump to page 402 in the book, and you can draw the pictures for 3 through 5 and 11 through 13, and we're going to go ahead and decide which of these theorems prove parallelogram. Okay, so here are the pictures you should have drawn, including the red markings, and you're trying to determine if there's enough information for us to prove quadrilateral. So here is the yellow box I referenced. It is on page 401, and this is the way that we prove parallelogram. Okay, so let's start by evaluating what we're given. We're given this pair of opposite angles congruent and this pair of opposite angles congruent. If you notice, the first one here says both pairs of opposite sides are parallel. We don't have that. The next one says one pair. Well, we have both pairs, and this is in reference to sides, so we're not doing that one. If you keep going down, we find this one here. The fourth one down says both pairs opposite angles are congruent. So next to number 3, you can either write both pairs opposite angles congruent, or you can write theorem 6-3-3. That's the answer to number 3. You say yes, and theorem 6-3-3. Number 4, what are we given? Well, we're given one diagonal that's bisected, and we're given congruent sides, one pair of congruent sides. So let's sit and think for just a minute if we have enough information to prove that parallelogram is a parallelogram, and the answer is actually no. Okay, and this last one here. Okay, for number 5, we have to think a little bit on this one. We're given a congruent side, one pair of congruent sides, and one pair of angles that really have nothing to do with the parallelogram, but because these angles are congruent, we can add parallel markings to this side. Go ahead and do that. Remember, a parallel marking is an arrow. And this side. It's an arrow here. This side is now parallel to this side and congruent to this side. Looking through our theorems, we see right here, if one pair of opposite sides are parallel and congruent, then it's a parallelogram. So this one's yes. You can either write out that whole phrase or put theorem 6-3-1. Okay, now you should try 11 through 13 on your own. Let me scroll down here so you can see the way the pictures are. In case you forgot your book, you can copy these down, and I want you to try these on your own. Remember, the answers are in the back of the book. So the answers, like I said, are in the back of the book for 11 and 13, and we'll go over 12 tomorrow. The next thing we're going to do is flip your paper over. You should be on number 4, and we're going to solve problems 9 and 10 from the textbook in this space. And then for number 5, we're going to solve problem number 14 in the exercises in the book together. So let's start with 9. 9 is asking us to show that quadrilateral BCGH is a parallelogram. Now it looks like a parallelogram, but remember, we can't assume anything. We have to prove it. So because we're given two pairs of opposite sides, an expression for two pairs of opposite sides, we're going to plug x in here and plug x in here. So you should be doing 3 times 3.2 plus 7 and 3.2 times 8 minus 9, and showing that those in fact are the same. Okay, typing this in on my calculator. Of course, I expect you to be doing the same. You can use your phone if that's the only thing you have handy. Typing x in, or 3.2 in for x, we get 16.6 for BC and 16.6 for GH. So we should write BC congruent to GH. Next, we're going to plug in 7 for y. 6 times 7 minus 14 gives me 28. And 3 times 7 plus 7 gives me 28. So I put CG equals 28 and BH equals 28. CG is congruent to BH. Therefore, since both pairs of opposite sides are congruent, BCGH is a parallelogram. All right, you try number 10 on your own. This will be part of your homework grade, so make sure you have it finished. You're going to plug in A here and B here. Now, I want to point out to you, what you're going to prove is that this side is congruent to this side, since A, when you plug in 19.5. And what you need to prove for the two angles is that they are, remember, they're consecutive. So these two values should not be the same. They should add up to 180 degrees. Okay, number 5 on your handout. Ask you to solve number 14 in the book. So this is what number 14 looks like. Number 14 asks us to show that the quadrilateral with the given points or coordinates is going to form a parallelogram. So you're going to prove that this is a parallelogram. So go ahead and take a minute and plot each of these 4 points on your handout. Be sure to label them J, K, L, and M. Pause the video now. And when you're finished, you should have the points that look like this. Okay? -1, 0 is J. -3, 7 is K. 2, 6 is L. And 4, -1 is M. Take your pencil and connect these to form the parallelogram. Now, let's think to ourselves, what is the method that we would use using a coordinate plane to prove parallelograms? So I'm going to pause for just a second and pull back up our little yellow chart from page 401. So which one of these rules for parallelograms is the easiest to prove on a coordinate plane? What do we know about a coordinate plane? We know that it forms lines. We also know that we can find the slope of those lines, and the slope is going to help us prove that both pairs of opposite sides are parallel. So you have a couple choices here. You can go ahead and count blocks and determine the slope that way. We will notice that the slope from J, which is down here, to K, which is up here, we can calculate by counting blocks. We go down 1, 2, 3, 4, 5, 6, 7, and over 1, 2, or right 1, 2. So our slope of JK is equal to -7/2. Then we need to compare the slope of the side opposite that one, which is the slope of LM. Let's count this one. 1, 2, 3, 4, 5, 6, 7, and right 1, 2. That also has a slope of -7/2, so you can say that JK is parallel to LM. Now let's find the slope of this side. This side at the top here is KL. KL has a slope of -1 over 1, 2, 3, 4, 5, so it has a slope of -1/5. and the side opposite KL is JM. It has a slope of -1, 1, 2, 3, 4, 5. Since those two slopes are the same, you can also say that KL is parallel to JM. Let me show you what your solution should look like. Okay, so here's a printed version of what your solution should look like for exercise number 5 on the handout. And remember, we were doing problem number 14 from the book, and it asked us to prove that the shape is a parallelogram. So we first found the slope. Now we counted, or you can use the slope formula, whatever you want. Remember, it's rise over run. We got -7/2 for JK, -7/2 for LM, -1/5 for KL, and -1/5 for JM. Because both pairs of opposite sides, don't forget your summary at the end, have the same slope, then the segments themselves are parallel. Therefore, JKLM is a parallelogram by definition. Okay, this is usually worth a lot of points, so make sure you get all of this written down. That's the end of the video. Make sure you finish the other exercises that I referenced, and we will do the rest of the worksheet together in class. Have a great night.